In this video, you're going to look at the least squares regression line. Now, this is just an alternative to finding the line of best fit. It's very complicated, but the good news is you don't have to go through the steps. The calculator does it for you. So really what you are learning here in this exercise is how to use your calculator to get a more exact equation when you've got a scatter plot. So it's sometimes referred to as the least squares method, and we used to go into a lot more detail about how it was actually how you actually use that least squares method, but we don't have to do that now. Please be aware though, if the question says using the least squares method or find the regression line, that you connect those words in a question to this process that you're learning in this exercise. So, like I said, you'll be relying on your calculator, and the first two steps on the calculator are exactly the same as what we did when we were finding the correlation coefficient. So that's really nice. Then just a little bit about the format for the equation of your line. So the line, we know when it's a straight line, and we only look at regression lines in the linear form, which means their equations are a straight line. We know from previous work, normally it looks like mx plus, and I'll stick with the c, although we used to call it b. Now it's going to be y is equal to bx, and it's this b value that the calculator will calculate for you, plus a. And again, this value a, the calculator finds for you. Now, there are some mistakes in the notes that really must be corrected. And so you can see that I've done that here. You can see that I've blacked out everything after. Oh, hang on, I'll talk about this next step. To recover the statistical data, press all clear while in the stats editor. Now, we've had to do this before, and we sometimes get a little bit nervous about actually pressing this all clear when we've actually entered our data, but that's fine. We need to do that. Now, we're going to actually recover if we're recovering A, then remember A goes in this spot of our equation. I think it's a little bit confusing because A is usually the first thing you have to write. No, in this case, A is taking the place of the C, or the B that we used to call it. So, to do that, it says, press AC. Then, to find the value of A, we go straight to second. Now, I know that under the black there, and possibly you've still got it, you can possibly still see it, and please cross it out. Underneath that there is another AC. Don't press all clear a second time at this point, not at this point. So, we're in stats mode. Just a moment. So I'm in stats mode. Let's just say I have just finished entering my data. I press all clear. To find the value of A, go second function, 1. See this stats vary written there? Anything written in yellow, you have to press the yellow second function button to access it. We want to be in stats vary. Next, we want a regression line. So you can probably see why we choose 5 next, the regression line. And there you can see, if we're finding A, obviously we want 1. Now, when I press equals, it's going to say there's an error because I haven't entered the data. There's an error. But what I will do is show you that those steps again when we get here and I fill the data into the calculator. But back to the calculator, let's say there wasn't an error there. To find, and I had a value for B, I would write my value for A down. The next step is to find B, press all clear. So you go all clear. And again, you go through this process. Second, we want to be back in the stats. We want it for a regression line, but this time we press 2 because we want the value of B. And equals, and it'll be the same. It'll say there's an error because I haven't added any data. I'll pause the video now, put the data in so that we can actually look at this example. Okay, so now you can see there on the calculator, I've entered the data. I'm going to now retrieve the value for A and then B. So I'm following the steps right here. The value of A. Back to the calculator. It says, oh, sorry, just before that, press all clear while still in stats mode. I haven't done that here, so all clear. We now want second, stats variables, 5 for regression line, and 1, and on my calculator you have to press equals to actually get the value, and it says that A is -22. So -22. So far our equation would be from y equals bx plus a, we'd have y is equal to, our a value is -22. Some of you might be thinking already, because this is height height and arm span, that our graph's going to cut down here at a -22. Well, actually, that probably isn't that unreasonable, because think about, does anybody have a height of 0? No. Even when you're born, you're going to start off with some height. So the graph actually makes no sense here at the height of a person being 0. So maybe realistically, a baby might be, I don't really know anymore, maybe 50 centimetres long, and they would have an arm length of whatever value we've got there, and so our line may actually cut down here if we extended it back to this unrealistic 0 height for them. You'll see it says actually later in the notes that we never do this. We never extrapolate. We don't extend these lines because in many cases it makes no sense. You can't use your data to predict outside the data that you have collected, because it's just giving you rubbish results. Okay, let's go on and find the value of B. So it says to find the value of B, press all clear. This time we do it. So we press all clear, we get out of there and go again. Second, 1, 5, because we want a regression line. And this time we want 2 because we're wanting the value of B. And we press equals and we get 1.1. So we've got that this is 1.1x minus 22. Now, this data is exactly the same data as that from example 4, which we actually covered, back in, I think it was in Correlation 502. So I'll just scroll back there and show you what the line back there looked like and see if it would sort of match this. So what do we know about this line? It's got a positive gradient. It cuts at -22. I'm not even sure that we're going to be able to see that on the graph for this very reason. The height didn't extend back to 0. Let's have a look at that. So yeah, here it is. Exact same set of data and graphed like this as a scatter plot, line of best fit drawn in. Yes, it's got a positive gradient, and no, this is exactly what I was saying. Height, it doesn't come back to height as 0. If we did extend these axes along and got back here to height as 0, which doesn't make sense, by the way, then you might find that the line cut at a negative value on the y or the vertical axis. I'll leave you to do the rest of that example, which just says to draw that graph that we've got, the 1.1x minus 22, draw that graph, and then use that graph to read off some information. So I can check that with you, see how you went with that in class at the beginning of next lesson. Just then actually formalising some of the comments that I've made, you can see here that just before that, remember how the syllabus said that you had to look at the at a spreadsheet for doing the same thing? Then the spreadsheet, you can see here it's calculated y equals 1.1 minus the 22. It's actually got the correlation coefficient squared value there. Not that we need that, but like I said, you can spend some time going through that if you have the time. Otherwise, let's focus on just some really important conditions around the use of a regression line. So, something to note. The bigger your set of data, the larger the number of data points, then the more accurate your line will be. That happens with that's the same as with all statistics. You should only use it to interpolate results. Now, what that means is I'll use this example here. Interpolation means that we can use this to predict anything from there to there. So anything between here and here. So we could say if someone had an arm span of 192, what do you think it would be? Or you could use that equation. What you definitely can't do is extrapolate, which means you would try to predict what's going on down here, outside the data. So we shouldn't be trying to predict what's happening there. We shouldn't be trying to predict what the outcome would be for any arm span less than 186 centimetres. Nor should we be trying to estimate or predict, using that equation, anything for an arm span greater than 199. Just be aware of that we should not make predictions that is different from the population from which the sample is drawn. Now, you have done lots of questions in statistics before where you have used your model, you have used your equation to predict what would happen if your graph was extended. However, in this case, just please note that you should not be using the data to predict outside the data set, the limits or the extremes, the lowest and the highest of the data set that you've actually worked with.